Alright, we're going to talk about solving rational inequalities. It's going to be kind of similar to what we did with solving rational equations the other day. And it also is going to combine with what we did when we solved quadratic inequalities using a number line to figure and using some test points. So let's go ahead and take a look. So here's your steps. So the first step is to rewrite your inequality as an equation. Solve the equation like we did last class. Then we're going to use the solutions and any rejected values that would be causing it to be undefined to create test intervals on a number line. And then we'll test the intervals, test our endpoints, and write an answer in interval notation. Alright, so we're going to go ahead and take this and rewrite it as an equation. Okay, we're going to go ahead and solve this. Now we can either solve this by timesing both sides by x minus 5, or if you want to try to cross multiply, that works too. It's the same thing, but I'm just going to multiply by x minus 5 to both sides. Okay, so x minus 5 is over here canceled, so we're left with 2x minus 7. Make sure we distribute, so we have 3x minus 15. Okay, move the 2x over, so we have negative 7 equals 1x minus 15. Add 15 to both sides, so we have x equals 8. We also know that x cannot equal 5 because that would make the denominator equal to 0. So when we go to make our number line, we're going to put on 5, and we're also going to put 8. Okay, so now we're just going to test these intervals. So for the first one, let's test a number that's left of 5. I'm just going to use 0, a little bit easier to work with. So I'm going to plug 0 back in up top. So we have 2 times 0 minus 7 over 0 minus 5. And is that less than or equal to 3? Well, that ends up being 7/5, which is just 1 and 2/5. So we know that is less than. So this is going to be a smiley face. That one works out. All right, let's try one between 5 and 8. I don't know, let's try 6. Okay, so when we do that, we get 2 times 6 minus 7 over 6 minus 5, which reduces to 5 over 1. And is that less than or equal to 3? It is not, so 6 is not going to work. Okay. Now let's try another one. Let's go, I'm just going to use 9. When we plug 9 in, we get 2 times 9 minus 7 over 9 minus 5. And see if that's less than or equal to 3. Let's go ahead and simplify that left side, which is 11/4. 11/4 is 2 and 3/4, which is less than 3, so we know that would work as well. So now I need to go ahead and rewrite this as an interval notation. Okay, so I'm going to go ahead and say that x is going to be, it works out when x is going to be to the left of 5, so that's going to be negative infinity to 5. And it includes 5 since it's less than or equal to. And then it also works for when it's, that should be a bracket, 8, and then anywhere to the right of 8, which is positive infinity, since that's the parts that were true for my graph. Alright guys, let's take a look at this example. I'm going to go ahead and rewrite it so that it's equal to 1. You don't always have to do that, but if it helps you to do that, go for it. Remember, we're going to multiply everything by what the common denominator would be. So this would be x minus 1, x plus 1, x minus 1, x plus 1, and then at the bottom as well, x minus 1, or at the right side, x minus 1, x plus 1. Okay. So now our x minus 1's cancel, so we're left with 5x plus 5. When we distribute, then we're left with, now be careful here, our x plus 1's cancel. So now be careful here, we're going to have negative 2x squared plus 2x, since this is technically a negative 2x, okay, equal to, well, this is just x squared minus 1 if I multiply it out. Now let's go ahead and combine like terms. So we have negative 2x squared plus 7x equals x squared minus 1. You could move the x squared and the minus 1 over to the left-hand side, but if you do that, then you would have to make sure we factor out a negative when we go to solve this quadratic. I'm just going to go ahead and add 2x squared to both sides, subtract 7x, and subtract 5, and get everything over to the right side. So I have 0 equals 3x squared minus 7x minus 6. Now when I go to factor this, well, multiplies the negative 18 but adds up to 7. That'd be 3x and x. Okay. Remember, it's going to be negative 9, positive 2. So this will be plus 2, and 3 goes into 9 3 times. Okay. So we're going to have x equals negative 2/3 and also 3. Okay. So when I go to make my number line, I have negative 2/3. I have 3. But also we make sure that you add or put on there the values that would make our original equation undefined, which would have been x equals 1 and x equals negative 1. Now let's go ahead and pick some test points. Okay? So I'm going to go ahead and start on the right side. So let's try 4. Okay? So I'm going to have, so I went ahead and plugged in those numbers. And if I simplify this is 5 over 3 minus 8 over 5. And I just plugged this right into the calculator, and I saw that it ended up being like 0.06 repeating. So I know that that's going to be less than 1. And since we're just checking to see the intervals, you can use a calculator. So this actually works out. Okay. Now I'm going to go ahead and plug in, let's try 2. So I have 5 over 2 minus 1 minus 2 times 2 over 2 plus 1. And let's see if that's less than 1. Right. And that ends up being 5 minus 4/3. Which I know if I do 5 minus 4/3, that's going to be bigger than 1. So this isn't going to work. So we're going to go ahead and put a frowny face, since this is not less than 1. All right, let's try another point. Let's try the test point 0. Well, I'm going to go ahead and plug that in. And I get negative 5 minus 0 is less than 1. So negative 5 is less than 1. So that works out. Okay. Another test point over here, I'd use just negative 3/4. And I just plugged it in the calculator, and when I did that, I ended up getting like negative 20/7 plus 12 is less than 1. And if I kind of think about that, negative 20/7 is definitely less than 12. So when I subtract those, I'm definitely going to have bigger than 12. So this does not work out. And last but not least, a number that's less than negative 1. And I ended up using negative 2, and it ended up working out. Okay. So now we have to do the intervals, which there's quite a few of them in here. So we want to make sure that when we do these intervals, we get all of these involved. So we're going to have negative infinity all the way to negative 1, which it won't include negative 1 since it's just less than. Okay. Then it also starts at negative 2/3 and goes to 1. And then we have 3 to positive infinity. Okay. And those are all the intervals that make this inequality true.